Absolute value equations and inequalities. Let's start with a definition. The absolute value of a number x, written like this with two vertical bars on either side of x, that represents the distance from x to 0 on the number line. Hopefully you remember that about absolute value, that it represents distance from 0. For example, the solutions of the absolute value of x equals 4 are 4 and negative 4. So the absolute value of x equals 4. That means the distance from 0 is 4. And there's two numbers that are 4 units away from 0. That's 4 and negative 4. So if you want to look at that on a number line, we have 0 in the middle, and we want a number that is 4 units away from 0. So of course we can have positive 4. That's 4 units away from 0. But then we can also go in the negative direction to get that negative 4 as one of our solutions as well, because it's also 4 units away from 0. Sorry, those are solid circles. They're filled in. I think the light glaring off the pencil was making it look like it was open. Those are closed circles. Okay, so that's going to be helpful when we're solving equations that have absolute value, something that has an equal sign. Let's look at inequalities. So if we have the absolute value of x is greater than 4, So if the absolute value of x is greater than 4, the solutions are all the numbers that are more than 4 units from 0. So more than 4 units from 0, if we represent that on a number line, open circle at -4, open circle at +4, and it's open circles because we want numbers that are more than 4 units from 0, not exactly 4 units from 0 and more, just more. This is strictly greater than, not greater than or equal to. So open circles at -4 and +4, and all the numbers that are more than 4 units from 0 are on the outsides of these numbers. So numbers that are less than -4 and greater than +4. To write this solution in interval notation, we're going from -infinity up to -4. And we have an open circle at -4, so we're not including that in our solution. So we're not going to use a square bracket. We use the union symbol to join our next interval, which is from 4 to +infinity. Okay, let's look at the absolute value of x is less than 4. Absolute value of x is less than 4. Those solutions are going to be all the numbers that are less than 4 units from 0. Okay, so let's look at a number line. Less than 4 units from 0, so we still have open circles at -4 and +4 because it's strictly less than, not less than or equal to. And all the numbers that are less than 4 units from 0 are all these numbers between -4 and +4. So this solution in interval notation would just be -4 to +4 with parentheses because we're not including those in our solutions. Now, if these were greater than or equal to, or less than or equal to, then we would have closed circles and square brackets. We would work it the exact same way. We would just then be including these numbers, -4 and +4, in our solution.
Miss Fulmer, did you see my chat?
Yes, I did.
Okay.
Okay, let's move on. So the types of problems that we're about to look at can look three different ways. We can have the absolute value of ax plus b equals k, where a, b, and k are just numbers, and x is our variable. Or we can have the absolute value of ax plus b is greater than k, or ax plus b, the absolute value of ax plus b is less than k. Those are the three options. Okay, so the solutions of these three things, we're going to write those a little bit differently. If we have the absolute value of x equals 4, the solutions are x equals -4 or x equals +4. We talked about that already. Okay, if we have the absolute value of x is greater than 4, the solutions are x is less than -4 or x is greater than +4. So this is going to be the same solution as when we worked compound inequalities with the word or. Then when we have the absolute value of x is less than 4, the solutions are x is greater than -4 and x is less than +4. So if we look at the three different types of problems that we're going to be seeing and compare them to these solutions, this first equation obviously is going to have the same solution set as this. This second one is going to have the same solution as this second one that we wrote. And this third one is going to have the same solution as the third one. So these equations and inequalities over here is how we're going to set up our problems in order to solve. All right, let's work some examples. We've got the absolute value of 2x plus 1 equals 7. Okay. So if we look back at what we just wrote down, the absolute value of 2x plus 1 equals 7 looks like this equation that's been set up. So our solutions are whatever's inside the absolute value is going to be set equal to this negative number and the positive one. And we'll have to work out both equations. So let me show you what I mean. What's inside the absolute value in this equation is 2x plus 1. So we're going to take 2x plus 1, and it can be equal to negative 7, or 2x plus 1 can be equal to positive 7. Because what this equation is saying is 2x plus 1, since it's in absolute value, we want to know when 2x plus 1 is 7 units away from 0. Well, it's 7 units away from 0 when it's equal to negative 7 or positive 7. So now we just solve both of these equations. Subtract 1 from both sides to get 2x equals negative 8. Divide both sides by 2, and we get x equals negative 4. Do the same thing in this equation. We get 2x equals 6. So x equals 3. So in order for 2x plus 1 to be 7 units away from 0, x either has to be negative 4 or positive 3. Let's graph this. On a number line, we just have closed circles at -4 and +3. And we can't really write this solution in interval notation because there's not an interval. It's just two numbers that are our solutions. Okay, so this is how you will work every problem where an absolute value is set equal to a number. Let's look at example 2. Absolute value of 2x plus 1 is greater than 7. So the absolute value of something being greater than a number, if we look back, the solutions are going to be whatever's inside that absolute value is less than the negative number and greater than the positive number. So this is how we'll set up our inequalities. So 2x plus 1 is less than -7, or 2x plus 1 is greater than +7. In order for 2x plus 1 to be more than 7 units from 0, which is what this inequality is asking for, it either has to be less than -7 or greater than +7. And now we just solved both of these inequalities. We get x is less than -4. Whoops, we get x is greater than 3. Okay, let's graph this solution. X is less than -4, so we have open circle at -4, and x can be less than that, so we shade the left side with an arrow pointing towards -infinity. Or x can be greater than 3. So open circle at 3, x can be anything greater than that, so we shade the right side with an arrow pointing towards +infinity. So in interval notation, this is -infinity to -4, or 3 to +infinity. So when you have an absolute value set greater than a number, your solutions should be on the outsides of those numbers because you're looking for numbers that are more than 7 units from 0 or more than whatever this number is from 0. Okay, we've got one more example. This will be example 3. The absolute value of 2x plus 1 is less than 7. Let's make it less than or equal to, just so we can have one of those done. So when we have an absolute value set less than a number, if we look back, the solutions are basically it's set up the opposite of the one we just did. We want to look at greater than the negative number and less than the positive number because we want to look at numbers between these two. So on example 3, that means 2x plus 1 is greater than or equal to negative 7, and 2x plus 1 is less than or equal to positive 7. Let's solve these inequalities. We get x is greater than or equal to negative 4. And x is less than or equal to 3. When we graph this solution, now we have greater than or equal to, less than or equal to. That means we're using closed circles at these numbers. So a closed circle at negative 4, closed circle at positive 3, and our solution are numbers that are greater than negative 4 and less than negative 3. So that's all these numbers between negative 4 and 3. So our interval, we're including negative 4 and 3 in our solution. So we should use square brackets, negative 4 to positive 3. That's our interval notation of our solution. Okay,